All right, starting 1.8, combinations of functions, composite functions. All right, so these properties here, most students have no trouble working with these properties, right? But it's this one on the bottom here that sort of throws some students off. All right, but before we get to that, let's just focus on the top four first. Okay, so f plus g of x is the same thing as f of x plus g of x. All right, they already gave me the functions here. So I have 2x minus 5 plus 2 minus x. So combining like terms, I have x and negative 3. So x minus 3. That's all there is to it. Done with that one. All right, then we have f of x minus g of x. All right, and replacing f of x with 2x minus 5 minus, all right, here's the first mistake many students make. They write this. What's wrong with that? Okay, I'm subtracting this quantity. Well, what is g of x? 2 minus x. So make sure to put parentheses around it and distribute that negative, because that goofs a lot of students. All right, so we have 2x minus 5 minus 2 plus x. Combine like terms, I have 3x, and then I have minus 7. All right, so 3x minus 7. All right, going on to fg of x, or f times g of x. We have f of x times g of x. Let's move this down a little bit. All right, so we have 2x minus 5 times 2 minus x. And we simply FOIL, since we're multiplying two binomials, and we get 4x minus 2x squared minus 10 plus 5x. All right, combining like terms, we get, and shifting pieces around, all right, we got the like terms here, 9x, and then minus 10. All right, and that's what we're left with. Can't do anything else with that. Going on to the next one, f over g of x is the same thing as f of x over g of x. And I have 2x minus 5 over 2 minus x. And there's nothing we can factor out here. Make sure you don't do that. Make sure you don't do that. All right, because there's a difference. If we were multiplying on top values and we're multiplying on bottom values, then you could start canceling the 2's out and the x's. But since there's a subtraction in between, no can do. All right, so there's your answer. Going on to the next example. And we're going to be applying the composition of functions soon. Oh, starting off example 2, use the graphs of f and g to graph h of x is equal to f plus g of x. All right, this is equivalent to this. F of x plus g of x. Okay, so how does this work exactly? Here I have g, here I have f. What's going on? I need to graph h. All right, so at negative 2, let's see how this works. H of negative 2. Well, what's that equal to? That's equal to f of negative 2 plus g of negative 2. Well, going by the graph here of f, at x is negative 2, what's y? Well, y is negative 2 here. All right, so that's what we get in return. This was our input, that's our output. Then for g, let's see where we're at negative 2. Negative 2 for x, what's my y? 1. So this is my input, that's my output. All right, and then I get negative 1. So h of negative 2 is equal to negative 1. So when x is negative 2 for h, y is negative 1. All right, and you apply the same process for the next 4 values of x. Negative 1, 0, 1, and 2. Same process all the way through, and you'll get these points. When x is 1, y is 1. When x is 0, y is negative 1. When x is 1, y is 1. And when x is 2, y is 3. And you get this graph. All right, that's all there is to it. On to the next example. All right, here we have f minus g of -1. So I have f of -1 minus g evaluated at -1. So I take this function here and I plug in -1 for x. So -1 squared plus 1. Then minus g of -1. So I take x and I plug in -1. Once again, make sure you put that quantity in parentheses because you may have to distribute the negative, but in this case we could just simplify it inside. Alright, so I have 1 plus 1 minus -5, so 2 plus 5, which is 7. Alright, going on to the part B, we have f of t minus 2 plus g of t minus 2. Alright, have to be careful with this one. This confuses a lot of students. Alright, so I'm taking f and I'm plugging in t minus 2 for x. So I have t minus 2 squared plus 1, and then I have plus g, which is x minus 4. So for x, I'm plugging in t minus 2. Alright, so that's the most important part. Once you get that, it should be a piece of cake. So you have t minus 2 times t minus 2 plus 1 plus t minus 2 minus 4. Alright, I'm going to have to FOIL here, and I get t squared minus 2t plus 4 plus 1. Sorry, that's a t there. Be careful with that. Plus t and minus 6. Alright, so let's just simplify here. I get t squared minus 4, so it's minus 3t. And then I have 4 plus 1 minus 6. So I get -1. Alright, that's all there is for that. Just be careful with the negatives. On to the next example. Alright, here's where we find the function composition. Alright, how does this work? So what does this symbol mean? It's not multiplication. It's a hollow circle. So this means the function composition. It's not multiplication. F of g of x. Alright, now how exactly does this work? Alright, so in this case, it's usually f of x, right, that we're working with. But now, instead of having an x there, you have g of x. So wherever I see an x in f of x, I replace it with whatever g of x is equal to. Okay, so I have f, let's see what we have here, 3x plus 5. So 3, what is x in this case? It's g of x, which is 5 minus x. So I have 5 minus x, and then plus 5. Alright, so actually really simple stuff once you understand the concept. Alright, done with that one. Next one, now just flipping it around, g of f of x. So for the function g, alright, here I have my x. I'm going to be plugging in f of x for x. So this is my f of x. I plug that in to x. Alright, and then what am I going to have? Let's see here. I have 5 minus x, which is 3x plus 5. Distribute the negatives. 5 minus 3x minus 5. Alright, so 5's cancel, and I get -3x. Alright, that's all there is to that. Alright, next one, f of f. So I have f of x. Alright, so here's my f. It's 3x plus 5. I'm going to replace my x with f of x. Alright, so it's a little funky, but you're essentially just plugging in the same function in for x. So here I have 3x, which I'm replacing with f of x, which is 3x plus 5, and then it's plus 5. So I get 9x plus 15 plus 5. So I get 9x plus 20. All right, that's all there is to that. Moving on to the last example. Okay, what do we have here? Find the domain of each function and each composite function. All right, so first thing I'm going to do is find the domain of each function. So what's the domain of f? Well, I have to figure out, here's my f of x, square root of x plus 4. I can only take the square root of a number that is not negative. So x plus 4 has to be greater than or equal to 0. So now I'm going to solve for x, and these x values represent my domain. So in this case, it's all real numbers. All right, such that x is greater than or equal to negative 4. That's my domain. Those are the only x values that work in the function. Going on to the next one, x squared. Well, let's think of what numbers I could plug in here that don't work. In other words, what makes it undefined? Well, nothing. I could plug any number in here and I'll get a y value back. So any number works. So the domain is all real numbers. Any number works. Now here's the tricky part for parts C and D. All right, so here I have the composition of functions, f of g of x. All right, and let's see what happens here. I have f, which is square root of x plus 4, but I'm replacing x now with what? G of x, which is x squared plus 4. All right, so what does this do then? Well, this changes the domain, essentially, for f. And now, what is the domain of this composite function? Well, I could plug any value for x in here now. That'll work. So it's all real numbers. So you're taking whatever the domain was for this function, and you're adding on what the domain is for that function. All right, and what do I have to add on? All real numbers. It covers everything. All right, going on to D, g of f. All right, so now I have x squared, and I'm plugging in square root of x plus 4. So I have square root of x plus 4 for x, and then I'm squaring it. So I end up with x plus 4. All right, but here's the tricky part. This domain is limited. All right, so originally, this domain was all real numbers, but then f was inputted, and it has a domain restriction. All right, the domain cannot be any values less than negative 4. So originally I started with all real numbers, but now it's restricted by what I've inputted. So the domain here is all real numbers such that x is greater than or equal to negative 4. All right, so this is a little tricky, but just follow these two examples and compare the two, and it shouldn't be too difficult for the concept to sink in. All right, now we're done with the lesson, and begin the assignment at the bottom of the web page. Make sure to ask questions if you have any.